objective for today is students will design and build the paper rocket using scientific investigation. Students will discuss variables and review the scientific method. On the lab sheet that I just passed out, you should see paper rocket labeled at the top of the first page. You will notice instructions say you will build a rocket that you will launch with about 4 inches of tape. Make your rocket in any way you want. It just has to fly as far as possible. Down below it, you have a set of instructions, and there are problems and a blank space. You will notice that it's got problem, hypothesis, and procedures, and then a space for conclusion. Why do I have it broken up like that?
They are parts of the scientific method.
Perfect, because those are parts of the scientific method. Look right here. It starts with identifying a problem, then the process leads to making a conclusion and communicating those conclusions. The part we're going to be working on today is the problem.
Oh wow, dude, that's gonna be like so cool.
Man, this is gonna be awesome.
We're gonna be
No,
so
work with
awesome.
rockets.
Holy crap, mama.
Listen to me first. You're going to pretend that you're engineers. Okay, you have gone to college, you got your degree, and you're making lots of money. I represent NASA. I come to you as engineers. I say that I need you to build me a rocket that can travel as far as humanly possible, using a limited amount of materials, a limited amount of fuel, and a very limited amount of time. You need to rephrase that as a problem. Discuss in your group right now.
Over here.
Yes?
Can we use the average of how far the rocket may go?
Yes, but you need to include more than that. Remember the 5 W's. You need to include what the problem affects and why it's important to fix.
Oh, okay, yeah. So it should be about the design, right?
Tell me more.
Well, we have limited materials and fuel. So something like, say, space exploration is important, but you need good rockets that can go farther with less fuel.
That's a good start. Now you need to include something about design.
Yeah, guys.
Rockets need to be designed so that less material and fuel is used.
If we don't solve this problem, NASA will run out of money and be shut down.
You're on the right track. Finish by saying what method you will use to investigate this problem.
Oh man, we're gonna do this rocket. It's gonna be like,
Fuel so hard.
Launch
We're gonna figure this out.
fuel and launch
Oh no.
for aliens.
Class,
We're gonna need.
as engineers in the real world, something you will encounter very often is you begin with a project. Say, we will give you $100 million, and if you can build it and do it in this amount of time, time being the very key part, if you can't do it in the time they've got, this is no use to them. To simulate the time constraint, you are going to work as a group, and you're going to have 12 minutes to build and design your very first rocket. Then we will go to the launcher and we launch. You will notice the materials, rulers and scissors if you need them. I will describe the launch process in just a second. I'm going to give each group one sheet of paper to build the rockets. Now here is our fuel. Looks kind of cool, huh? It's a bicycle pump, just an air pump. You can come and have a closer look if you need to. It's going to be almost exactly like this. It's going to go shooting down. Here's how it works. Here you have your pressure valve. You have to make sure the valve is closed. Right now, it is open, so you close the valve. and you start pumping. On here, there's a gauge. It says 20, 40, 60, 80, 100, and 110. What do you think that is measuring?
PSI.
Gordon, you're weird.
What does PSI measure?
It measures pressure.
And what does PSI stand for?
Pound per square inch.
So we're going to add the amount of air into this thing. We're going to do about 20 PSI. Now what if I say this group here will do 20, that group 25, and this group does however much they want. What do you think that will do to our experiment?
I don't know.